computer solve problems. We can clearly see that computers solve problems in a seemingly intelligent way. Where is the intelligence coming from? Where is the intelligence coming from? Intelligence coming from different types of IQ levels and based on the hard work intelligence comes from. There are numerous responses to Fairley argument. The system response. The hardware by itself is not intelligent. The hardware by itself is not intelligent. But a combination of the hardware, software and storage is intelligent. But a combination of the hardware, software and storage is intelligence. So what is the hardware? What is the software? And what is the storage is nothing but the intelligence. In a similar way, we might say that a human brain that has had no opportunity to learn anything cannot be intelligent. It is just the hardware. So whatever machine is doing, which we can call it as a hardware process. Whatever the software is doing, some of the machine, some of the human being activated is nothing but the software. And some of the storage capacity, how much memory is there in the particular storage capacity, how much memory is there in the particular storage capacity. The robot response, a computer is wide of senses and therefore symbols are meaningless to it. But a robot with sensors can tie its symbols to its senses and thus understand symbols. The brain stimulator response. If we program a computer to mimic the brain with a neural network, we can apply the neural network in a different manner. So every neuron is connected with one and each another. And what is the convolutional neural network? All the positive and negative symbols are included according to the human brain, which we can call it as a one type of neural network. Then the computer will have the same ability to understand as a human brain. Then the computer will have the same ability to understand as a human brain. We need to understand the computer ability. So based on the human brain, the computer will understand what is there in the particular aspects. Brain versus computer. And in AI, we compare the brain or the mind and the computer. In AI, we compare the brain and the computer. Our hope, the brain is a form of computer. Our hope, the brain is a form of computer. Any type of brain is a form of computer. Our goal, we can create computer intelligence through programming just as people become intelligent by learning. But we see that the computer is not like the brain. The computer performs tasks without understanding what it's doing. The brain understands what it's doing when it solves problems. So there is a different manner the brain and computer. So brain will look into all the intelligence and the computer will look into the perform task without understanding what it's doing. That is the main difference between brain and computer. Symbol grounding. One problem with the computer is that it works strictly syntactically. OP code 100 11101 binary code translate into a set of microcode. Instructions such as move here suffix 16.31 to MAR. Signal memory read move MBR to AC. There is no understanding. X equal to Y plus Z is a meaningless to the computer. The computer does not understand addition. It just knows that a certain op code means to move values to the adder and move the results elsewhere. Do you know what addition means? So, if so, how do you prescribe meaning to less? How is this symbol grounded in your brain? Can computers similarly achieve this? So recall snacks restaurant script. Does the computer know what the symbols waiter or PT rants represent? Or does it only have code that tells the computer what to do when it comes across certain words in the story or how to respond to a given question? Two AI assumptions. Assumption is nothing but assuming something. We can understand and model cognition without understanding the underlying mechanism. That is, it is the model of cognition that is important, not the physical mechanism that implements it. If this is true, then we should be able to create cognition mind out of the computer or brain or even other entities that can compute, such as a mechanical device. This is the assumption made by symbolic AI researchers. Cognition will emerge from the proper mechanism, that is, the right device fed with the right inputs can learn and perform the problem solving that we as observers call intelligence. Cognition will arise as the result or side effect of the hardware. This is the assumption made by connectionist AI researchers. Notice that while the two assumptions differ, neither is necessarily mutually exclusive and both support the idea that cognition is computational. Problems with symbolic AI approaches, scalability, can take dozens or more many years to create a useful system. It is often the case that systems perform well up to certain threshold of knowledge, approximately 10,000 rules, after which perform accuracy and efficiency degrade. Brittleness, most symbolic AI systems are programmed to solve a specific problem, move away from that domain area, and the system's accuracy drops rapidly rather than achieving a graceful degradation. This is often attributed to lack of common sense, but in truth, it is a lack of any knowledge outside of the domain area. No or little capacity to learn, so performance accuracy is static. So, what is the static? Fixed number of elements are there, which we can call it as a static. What do you mean by dynamic? Depends on the neighborhood values, extract all the information from different resources and put it into a particular place is called the dynamic. Lack of real-time performance. Lack of real-time performance. So, uh, lack of real-time performance. So, we are not going to do exactly what is there in the different real-time performance. So there is a degraded information which we can call it as one type of lack of real-time performance. So that will give you the exactness what is there in the different platforms. Next, problems with connectionist AI approaches. No more a sense of temporality. The first problem can be solved to some extent. The second problem arises because of a fixed size input but leads to poor performance in areas like speech recognition. Learning is problematic. Learning times can greatly vary. Overtraining leads to a system that only performs well on the training set, and undertraining leads to a system that has not generalized, no explicit knowledge base. So there is no explicit knowledge base. So there is no way to tell what a system truly knows or how it knows something. No capacity to explain its output. Explanation is often useful in a system so that the user can trust the system's answer. That's the main advantage. And so what does AI do? And there are different types of techniques are there. You need to identify it, you need to solve it in a different solve the problem. And what is search? And there are searching techniques are there. Uh, DFS and BFS are two searching techniques. Search spaces and types of search. So what are the different types of search spaces and what are the different types of type spaces are there? So these are the some of the type spaces and type searches. So you can apply the algorithm. So look at the algorithm here. You can solve the algorithm in a different manner based on the different types of problems. Search algorithms and representations. Just look at the algorithm. What are the different types of techniques are there? Breadth first search, depth first search, best first. We can call it as a heuristic search. Hill climbing, limiting the number of flights, minimize alpha beta pruning, adding constraints, genetic algorithms, forward versus backward chaining, and there are different types of techniques are there. A brief history of AI in 1950 and the 1960 what has happened, 1970 what has happened, 1980 what has happened, 1990 what has happened, today the new old idea. So